In this video, we'll talk about the Scullery, otherwise known as the crude dishwasher. I will show you the components that are inside of it, along with the schematic. Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video.
This is the crude dishwasher, or often referred as the Scullery. All the Sculleries are very similar, but they got two methods of heating. This one, as you can see, is the steam method. Gas turbine shafts will have heaters instead of steam. Here I got two schematics side by side. If you notice, this one over here energizes a contactor for the heater. So therefore, that's not the schematic I'm gonna use. The one that I'm gonna use for my case is the one that controls solenoid valves because, well, like I said, ours open and closes steam solenoids for heating. All right, take it out. To drain it, just undo the lever that corresponds to each tank. Now that all covers are being removed, and including that one, let me talk about all the components. So, as you already know, trays get fed into this place and they washed away. So therefore, this is my wash tank, this is my rinse tank, and then this is my final rinse. Starting from over here, we have a junction box, as you can see there, and that junction box, well, this is the main conduit. That conduit, it brings power, or it brings connections from that J box. We'll talk about that later. So here, that is my temperature probe, okay? It goes into this J box, and then also we got our floaty, which is this one over here. Here we got a solenoid. By the way, all of this is 24 DC circuit. And in here we got to this door switch. On the other side, we got the same setup. So we got, you see our switch over there, and then on the back over there, all the same components to include our solenoid valve. Now, this solenoid valve is the one that allows steam, so whenever it is energizes, it opens and allows steams to go into our heater. This is a steam heater. Inside here, we have two sensors. This is the floaty that lets me know, well, let the system know if there is water or not, and then there is a temperature sensor. Based on whatever the temperature of this is, the system decides if the solenoid that allows steam to go through here should open or not. These gauges over here are just for analog readings, for the operator to see. And if I look in the inside, that is the probe right there. There is no electrical connections going to it. In the other side over here, we got again the duplicate of what I just showed you, the temperature probe and the floaty, along with the heater. Doors are always permissive, that the door had to be closed for you to be able to start the system. All the way back over here, you see this switch over here, and when the tray comes in, it's supposed to hit it. When it hits that switch, well, if you can hear it, I'm gonna press it. There is a micro switch over there, and the whole purpose of that is just to energize this solenoid so that as the tray is leaving, there pretty much water rains, hot water rains on top of it to do, like I said, that's the final rinse. Down at the bottom, we got our motors. So, safe to say, this is my rinse motor, and that is my wash motor. They are 440. This is my conveyor belt. Now, if a tray gets stuck in there that doesn't want to move, it will put too much tension into this, and then there is this switch over here that will eventually get pressed, and that will cause the whole system to stop. And here toward the end, so once again, that's my rinse solenoid, and this is my booster heater solenoid along with the booster heater temperature sensor. And then the main conduit over here, all of them, they just come in, as you see, and it follows into this main terminal box. Now to talk about this terminal box over here. So if I look at the schematic, the door switches, here I got number 2. This over here is connected to here, so therefore this is terminal 2, and therefore, and this one over here is terminal 13, and this is terminal 9. So we're gonna test our door switches right now. I'm connected there to 13, and there to 2. So I got my multimeter nose, and you see it's shorted. Make sure you catch the door. I got my multimeter there, and I'm gonna open the door. And I'm gonna close the door. And I tested my switch. Now the other switch is 13 and 9, and that's exactly what I did. I just simply left the green one at 13, and the other one I moved it to 9, and look what I got. Ready? Now you can stop. I want to read my flow switch, and since it's connected to the circuit card, well, that's what I'm gonna do. I'm gonna read it from the circuit card. As you can see, I'm connected to the circuit card, and I got the flow switch, a multimeter connected to it. So go ahead and close the flow switch. Simulate that it's full of water. Now simulate that it's empty. And full of water, please. And there, we tested our flow switch. So here we got our circuit cards. This is my flow circuit cards, or actually SSRs. And then these ones are our temperature circuit cards. So the temperature probes are connected right here. So that's temperature for our wash cycle, and then this is the temperature probe for our rinse tank. Now this is the floaty for the rinse tank, and the floaty for the wash tank. If you see, white and black are powered; they are common. So we always got common potential to all of the cars and the SSRs, as you see. Black, well, it always comes in and powers these orange floaty SSRs. And let's talk about this one over here, the rinse. Whenever the floaty that is connected to this one shorts, then the system, this over here, or this SSR, it will short this contact over here, and it will put black potential into the orange cable. Now the orange cable will energize the circuit card. And that makes sense, because we don't want this car to work whenever the tank is empty. So if this one says that there is water, it will give power to this circuit card, and now this circuit card will sense via these wires the temperature of the tank, and then it will decide to energize the solenoid for the steam tank. If this was an electrical heater system, then it will energize the contactor for the heaters. And you definitely do not want to energize heaters when there is no water in there, because they will burn out. So these, they work identically as these two over here. Once again, temperature probe. This over here is powered to power the circuit card. We always got this one. This is conditional power. We will only get power over here whenever this one says that there is water. And this one goes to the rinse steam solenoid, and this wire over here, this yellow wire, it goes to the water solenoid for the wash tank. So when you're looking at these two over here, so we got the yellow wire over here, and we got our blue wire over here. Those would be these cables over here. So whenever this one says that there is water in the tank, it will allow power to power this car over here. And then if this car measures the temperature, and if it decides that the temperature is not correct, it will energize, it will put this potential into this point, energizing this solenoid, and therefore the system will start to heat up. This is my wash and this is my rinse solenoid. Let's look at on the schematic. So we got one card. This one over here is actually the SSR. The SSR, well, it has power, it has white and it has black power, but then also monitors the level. So if this one closes because there's water in there, this circuit card or this SSR will close a set of contacts, will now allow this black power to go into this orange cable to power the circuit card. And the circuit card will monitor the temperature probe, and if it decides that the temperature is not as hot as it should be, then it will close a contact. We will put this potential here, and that will energize the solenoid. For this case, it is the ring solenoid. If you look at the schematic, well, we have a lot of motors, but pay attention to this. There is only one contactor. Well, sometimes there is another contactor if they use this, the unloaded push-out motor. But if that's not the case, one motor provides power to 1, 2, 3, 4, 5, up to 6, up to 5 motors. Notice that each one of them has its own overload. So here is my main contactor, and when this contactor energizes all of those motors. But all that power gets distributed and it gets sent and it gets jumpered, as you see over here, to all of these overloads. And then after the overload is when it goes to each motor. So if the one that's connected to this motor, if that one motor gets stuck and it starts drawing too much power, this overload will open and it will cause this contactor to de-energize, stopping all motors. As I always say, these are the sensors, and these are actually the associated switches. If you see that one over there, that's overload 5, and that corresponds to this sensors number 5. And over here, so down there, well, we will get 440, and it will just be monitored going through this place over here. This inside there is the sensor that determines how much current is going through it, and this over here, this is the switch. These two cables over here, see how they are connected in series? These are my series connections over here. Now, you will not have all the motors. In my case, I only have my wash pump, my rinse pump, my conveyor pump, and then my conveyor eject motor. This motor only comes on whenever this button gets pressed, at least for our system. Inside this other junction box, there is a contactor that whenever that contactor energizes, that's when this guy energizes. As you could imagine, not only has a contactor, but it has its own overload protection for that motor. To energize the main contactor, we gotta meet a lot of permissives. Some of them are CR1. CR1 means that the doors are closed. And this is what I mean. If these two are closed, this relay should energize. And by the way, these relays are here. CR2 is my conveyor jam. That is the one switch that I showed you earlier that is inside there. I look everywhere on our Sculleries, but I cannot find this switch, so I'm assuming we might not have it. And to prove that, earlier I went ahead and I actually had the system with really cold water in there, and I energized it and it started. So therefore, I don't have this switch in the system. And then my stop and start switches, well, they are just located on the door panel. I'm not gonna go over the transformer because transformers are transformers, fuses are fuses, and terminal board connections are just terminal board connections. put our system back, obviously I need to fill it up back up. Are being called because this steam Scullery doesn't get up to temperature, and often the problem is not that our solenoids go bad, it's that people decide, well, because it gets too hot over here, the steam, they decide to close the steam drain valve, and this valve should always be open to allow steam to go out. If the steam cannot go anywhere, well, it's not going to circulate and it's not going to keep at the temperature. To talk about the soap dispenser, I won't say much. I do notice that I suppose this is power coming in, and then this wire over here, it goes to the actual dispenser itself. And then I traced this wire over here, and it goes all the way to the back, down underneath, and it comes all the way there when I got my hand, and it comes in into this sensor. And I guess, and I was just gonna say, I guess it detects turbulence. So whenever you press start, the water starts getting agitated because of the pump, and that maybe just is what allows the system to know that it's time to dispense soap. Now that is a theory. I really haven't verified how that actually works. This thing had never gone bad for me, so I never really troubleshot it. So therefore, I don't have any experience. But I thought I would share my thoughts on that.